Next, we want to discuss how lines intersect with other lines and planes, and how planes intersect with other planes. So the first one, we have intersecting lines, line with line. So if we have, let's say, line L going this direction and line M going this direction, notice that the intersection of those two lines is a point. Okay? Next, if we have parallel lines. Lines are considered to be parallel if they never touch but lie in the same plane. So we have a plane and we have line L and line M, and they're going in the same direction and they never touch. So that would be considered parallel. Next is skew lines. Skew lines are lines if they never touch, similar to parallel lines, and do not share the same plane. This one's very difficult for students to understand on paper, so I usually like to think about, if you're sitting in a room, do you see the crease in the ceiling on one wall that you're sitting in? Okay, and then let's say another one on a different wall, but on the floor, where the floor meets the wall. Okay, these are two lines. They do not share the same plane, yet they're never going to touch. One is up on the ceiling, one is down here on the floor. They're in two different planes, and yet they're not going to touch. Okay, so when you're describing this in your classroom, you can actually point to lines in the ceiling and point to lines on the floor so that you can show them that they're not going to touch, but they're not really parallel. Parallel lines have to be in the same plane. Alright, next we're going to talk about how lines could possibly intersect with a plane. Okay, so the first one is a line intersecting a plane, where let's say we have plane P here, and we have a line shooting right up in the middle of that. You have a dotted line here because you kind of can't see through it, okay, and then a solid line at the bottom with an arrow. So right here at the point, it comes through your plane and keeps going down. Now the intersection of a line that does not lie in the plane, okay, because this line isn't in the plane, this is intersecting the plane. So the intersection between the line and the plane is just a point. So this point, we'll call that point A, okay, where the line intersects the plane. Okay, a line could be totally contained in the plane. So let's say you have plane P here, and your line lies completely inside the plane. Or you could have a plane P and a line being parallel to that plane above it, never going to touch it. It's not going to come down and intersect it like the first example, but it's parallel to it, and it's above it or below, and those are the three ways that a line could interact with a plane. Next, we're going to talk about planes with planes. So these are really much harder to draw, so I gave the drawing to you. The intersection of two unique planes is going to be a line. Notice that you have in my picture, kind of the brown or the tan plane, plane alpha, that's what that means. And then we have plane beta, which is in blue, and they're intersecting here, and that intersection turns out to be a line. Line AB. And the other option is two parallel planes. So if planes are parallel, then they never touch. Okay? So those are the ways that lines could intersect with lines, lines can intersect with planes, and then planes could intersect with other planes. Let's look at this shape. This is a three-dimensional shape. It's technically a pyramid. Let's find some of the questions here. Find the intersection of side AEB. So side AEB, I'm going to color this AEB, that's this blue plane right here, and side EBC, so that's this plane right here. So the intersection between these two planes is going to be the segment right in the middle, which is going to be segment EB. The way we write a segment is a line on top of the EB without any arrows. So the intersection of those two sides is a line. All right, now I'm going to erase that. Find the intersection of segment AD. So AD is this one in the back here. And CD. So the intersection between those two segments is just a point, and that point is D. All right, let's see what else we got. Find the intersection of side AED. So that's AED here in the back triangle with segment EB. So the intersection is going to be just a point because the intersection of a plane and a line could possibly just be the point, and that point is E. Okay? Awesome. Next we have parallel lines, just a definition here with some notation. We've already kind of talked about parallel lines. We said that they are lines that never meet but are both included in the same plane. The notation to indicate that two lines are parallel is we have, let's say, line M, and then you have two slashes, N. So these two slashes are kind of like parallel lines. That's how I kind of think about it. M is parallel to N, so that's how we would write it. And here's an example. The notation for perpendicular. Perpendicular lines are lines that intersect, but intersect specifically at a right angle here, okay? So the right angle, you just have to have like a little, kind of like an L shape in there to denote that that's a right angle on the image, okay? And we have line M. Because there's a right angle, we know that's perpendicular, and the way we write that notation is M is perpendicular, so it's like a vertical line, then a horizontal line meeting it at the bottom is perpendicular to N. So M is perpendicular to N. So those are the notations for parallel and perpendicular. Okay, for our next example, it says identify the parallel and perpendicular lines in this figure. We have four lines, line L, L1, L2, and L3. So we can identify that L1, L2, and L3 are all parallel. So we would write L1 is parallel to L2, which is parallel to L3. All three of these lines won't ever meet, and they're parallel to each other. Next, we have perpendicular. It looks like this line L, because there's a right angle on each of these that intersect with the orange lines, they are all perpendicular. So L1 is perpendicular to L, L2 is perpendicular to L, L3 is perpendicular to L. So those are all the parallel and perpendicular lines in this figure.